Hey everyone, sorry for the slight delay. I think I had some slight network issue. I could not connect ahead immediately. But yeah, let's not take up too much time and let's get started. Now, getting back to where we stopped, we just took a look at async processes. The next thing we're going to take a look at multi-threading processes. Now, here's the thing. Think about this. Let's say, uh, okay, I'll give you two reasons why multithreading is quite important. One, from CPU usage perspective, the other with perspective of time. So these are the two perspectives that we will look into. Right. And prior to that, I just have one minor request before we go ahead. Um, I s- I'm still having some network connectivity issues at my end. I might need to switch it. So please give me just 1 or 2 minutes at maximum. I'll be on mute. I'll just reconnect with my network. I might go offline and be back within a minute, and we'll continue ahead. It should not take more than a minute or two. So please wait for this. So kindly hold on. Right. So again, yeah, sorry for the slight delay. I think I just changed my network and this should be fine. I'll start to get some volume so the previous one. Yeah, please get that. Let's get back to where we go. There are two main reasons why we opt for multi-threading. The first is CPU, and the second is Whenever we want to say that one operation, in terms of CPU, if your CPU is a dual core processor or a quad core processor, and you want to perform certain operations on them, if you have four threads running simultaneously, you can make use of all the cores of CPU to the fullest and simultaneously work on your operation. That is one thing. But more than that, will it for time? Think about this. A user gives an input. When a user gives an input, you need to perform parallel operations, both of which are not having anything in common. Now, this is the important point that we need to know. Oh, I'm so sorry for that. I think once I reconnected, the microphone
That's
was
better.
not talking. Yeah, yeah. I'm terribly sorry for that. Terribly sorry for that.
That's okay.
Right, going back to this, when we talk about CPU usage, you can use all the threads simultaneously. Because we have a multi-threaded application, each function in your code can run as a separate thread. Since each function in your code can run as a separate thread, all of them can run simultaneously together. That's the whole point. Another thing is, let's assume once you provide an input to your code, you need it to perform two parallel set of operations. The first operation is given, let's say you have some text. Given some text, the first operation is to, I'm just giving some simple logic that we perform. I'll also give you a scenario where I have used this over the past week for reference. Let's say you have some text. You want to find out what is the length of the text, and you want to find out how many vowels it has at the same time, because both of them are independent of each other. The first operation you can perform, as well as the second operation. The first operation as well as second operation should be performed simultaneously. Only at that point of time, you can see that you can save the time where you'll calculate the length first and then calculate the number of vowels in it later. So to save the time of performing this operation sequentially, we'll perform them parallelly. Multi-threading helps you perform parallel operations a lot. I'll give you a simple scenario where we have used this as of late. I had a particular client who asked to perform the following operation, where they have given 36,000 files, and all these 36,000 files should be translated from Swedish to English. And when it is translated from Swedish to English, within English, it should be converted. Sorry, yeah, once translated from Swedish to English, when it's translated to English, it should be converted to a different format of file that they expect. So this is a sequential thing. You cannot parallelize this. I have to convert it from Swedish to English, and only then I can convert this English document into a particular format. It's not like I can do parallel operations where given an image, convert it to black and white at the same time while captioning it. That is, convert it to black and white, and at the same time, figure out what is happening in that image, get a caption. Once you do that, combine the caption and black and white image back together and provide it to the user. Instead of sequentially performing this operation, parallelly helps. But here, there's no room for parallelization because I need to do the first task and only then I can do the second task. Here's what we ended up doing. We ended up creating two threads. The first thread will perform Swedish to English conversion, and each English conversion, once it is done, it will store that English conversion output in a database. The second thread will keep looking at the database and it will keep waiting. The moment this Swedish to English conversion is done and that English content is there, it will take it up and then it'll convert it into its proper format, and then save the file. Now you might think, hey, it's not like too huge, it still has to wait, right? But think of this. I can perform 20 Swedish to English document translations. Once they are stored in the database, when I'm performing the next 20, these are being translated, and simultaneously, the previous 20 will be formatted and saved. So it doesn't have to be like Swedish to English, then change to the format, then save. Again, Swedish to English, then format, then save. Instead, it'll be like Swedish to English. Simultaneously, it'll keep performing in one thread, and this will take up in another thread and perform for the second document format, for the third document format, for the fourth document format. So you can see it still performs parallelization, though this task is not a parallel task. You can utilize one task to another task combination to make it parallel. That's the whole advantage of this. That's the whole purpose of making it happen, right? So yeah, this is one thing I wanted to show with an example of where you can use parallelization, even though certain tasks or applications are not meant to be parallelized. So just one thing I wanted us to take a look at. Now, with this understanding, we can go ahead and take a look at multi-threading. The whole idea of multi-threading, whenever we talk about it, is that let's walk through this first. Each thread will run a separate function. Once each thread runs a separate function, you can perform parallel operation. But how do I make each thread run a separate function? We have to store it in a thread format first, the function. And once we do that, we just need to use start method. The moment you call start method, the thread will start. And there's another method called join. The purpose of join method is to know when this thread has finished its operation. So the moment the thread has completed its entire set of tasks, its entire set of operations, you execute join function. That's the whole process, or that's the whole purpose. That's how it works out. Now, let's go ahead and try this out and see how this works. Let's remember start to begin a thread, and to get to know when the thread has ended, we use join. And another question, why do we need to know when the thread has ended? Why do we need to use join? In case once you have completed your entire thread, you want to be notified, you want an email to be sent to you, or you want a message to appear on the screen, or whatever it could be, you can perform them after the thread join is done, for example. That's why we use start and join as two specific functions here. So let's start with this. Now, to do this, I'm gonna import, oh, okay, before that, let's do an application without threading. I'm gonna create two simple functions. Count forwards from, let's say, start to end, and then count backwards from start or from end to start particularly. So count forwards is going to do a simple task. For I in range of start to end, I'll just print I. That's it. Count backwards will do the opposite. For I in range of end to start, and since we are going backwards, I'm going to add -1. I'm going to print again I. These are the two functions. I'm just going to call these functions. So if name is equal to main, again, just a habit of using this to differentiate every other part of the code with the code that's supposed to run at the start of the program. That's why we're doing this, nothing else. Here, I'm just going to run count forwards 1 to 6, and then count backwards 10 to 5. That's it. Once you execute this. Oh, I am so sorry. It's supposed to be okay, 6 to 11. Um, sorry, 5 to 10. Because I'm taking this variable as start, comma, end, but here I'm reversing them. So one minor mistake, please ignore that. Let's take a look at this. Now, if you observe, I get 1 to 5 printed forwards, then 10 to 6 printed backwards. Now, you may not think this is a task that takes too much time. So to make it a task that takes too much time, let's import time. And for each print, I'm going to use time.sleep of 2. We're going to sleep for 2 seconds within this application. And I'm going to do the same thing even here. Now, if you run this application, we get to see and realize that this first function takes a lot of time, and only then second function gets to execute. If there were only a way to make sure both of them execute